Okay, so this is mechanics part 3, and we're really now diving deeper into those big 5 equations. So the big 5 equations are listed here. That's the velocity down to the vf squared, the vf squared one. And so the first one was above the line. That's the only one that deals with constant velocity. All the other ones below deal with constant acceleration. So for this one, a equals 0 and not part of the equation. There is no here. Velocity is the same at all points, and it talks about the average velocity in there. Here, constant acceleration, these all include acceleration as part of the equation. Velocity is changing. There is an initial and a final velocity. See where we see the final velocity, v initial, v initial. This one doesn't have a v final, but this has a v final and a v initial. This one sometimes is the one that confuses students the most. It has the change. Remember, the triangle means the change in v over t, which doesn't mean average velocity. It means the v final minus the v initial over time. That is the one that has the hidden v final velocity and initial velocity. So when we're determining what to do, we need to think about picking the best one with only one unknown. So the steps are: determine the type of motion. Remember, we've talked about that the 3 types of motion are rest, constant velocity, constant acceleration. Those are the 3 types of motion. So we determine the type of motion, then you write down all your knowns, write down your unknown, and then determine the equation with only one unknown. So which formula do you use for this question? A rocket initially at rest on the ground lifts off vertically with a constant acceleration of 2.0 times 10 to the 1 meters per second. How long does it take the rocket to reach an altitude of 9.0 times 10 to the 3rd meters? Okay, so we know that this is a constant acceleration, so we are not going to be using the first one. Here are our knowns. Which of this question is it? 1, 2, 3, 4, or 5 is of the formulas are you going to use to do this? You're going to answer in the puzzle. Now, in the next question, a car initially traveling at a speed of 16 meters per second accelerates uniformly to a speed of 20 meters per second over a distance of 36 meters. What is the magnitude of the car's acceleration? So we also know this is another one, a constant acceleration. So we know it's not number 1. But is it 2, 3, 4, or 5? Which one of these is it? So we know it's constant acceleration. Now we're going to write our knowns. So we know our v initial, we know our v final, and our distance. Which is the formula that we're going to use?